Hi, thank you for joining today's session, A Line of Sight. Envisioning a responsible agentic AI, RISE². My name is Iftach Or. I'm the co-founder and CTO at ActiveFence. In today's talk, we're going to discuss concepts and principles of responsible agentic AI, a framework for developing and governing autonomous AI in systems with accountability and responsibility. We'll explore practical approaches to building and deploying agentic AI safely and securely, to ground these ideas in reality and not just stay in theory. We'll also share real-life examples of emerging risks that we have uncovered through our deployment of agentic AI systems across different domains, and we'll discuss how responsible agentic AI practices can mitigate them in practice. I want to set the stage for agentic AI and then get to the juicy part of the presentation. I live in Greece, as was mentioned before, and I had a conversation with one of my friends here, and as he wanted to say agentic AI, he said in Greek, praktoras AI, which to me was a bit strange. Praktoras really sounds like practical or practicing. And I went home and I did some research, and I realized that kind of true. Like the praktoras means in Greek an agent, but the origin of the word is very interesting to me. The base word is for praktoras is actually ago, which means to lead, to guide, or to act. So many thousands of years ago, this is kind of the word it started from. And this reminded me of another word that is very commonly used today, which is ego. It sounds kind of almost the same, but it's not from the same origin, but it means me, myself, I. So to me, I found it very interesting to have these two very similar words actually together defining an agent, someone who acts on my behalf. So I think this definition that I realized a few months ago really helped me kind of understand what is actually we are trying to build here and de-risk. So something that can act on my behalf poses like new types of risk that are usually not that common out there in cybersecurity and safety. The first thing is that if you look at the definition, it's to lead. We are letting something else lead us. So even if we have a human in the loop that actually takes the decisions, still someone else gave us two options. So when I'm offering my kids the option to choose between pizza and pasta, they don't have really free will. I propose two options to them. So same can happen with agents. The second thing is that, I am what I do. Like, humans are the sum of their actions to some extent, right? So when agents can act on my behalf, this means that if the agent is misaligned, this means that the agents can over time change who I am. And that's a new type of risk that we didn't see much before. But if I take it from the self as a human being to a more business commercial level, and we say the company, an enterprise, is the sum of actions that this company is doing, and the agents are going to take action and do that on behalf of the company, then an agent misalignment, meaning the agent will change the self of the company. So this means that if an agent is misaligned, it will change the brand of the company, the compliance of the company, the reputation, and everything company. And I think this sums up why today enterprises are having a very hard time to feel comfortable deploying agentic AI in production to real business critical operations. So from philosophy to practice, before we do a bit of discussion, I want to show the numbers we have Satya and others talking about that by the end of 2028, we'll have many billions of agents in production running, doing stuff. So let's do a bit of math for the people in the crowd who actually do evals for agents. So if we'll do this equation of, let's just take 2 billion agents, not the high number of agents in the range, 2 billion. And for each of them to be statistically significant, we need to do 2,000 evals. And we need 10 iterations of fixes to align this agent. And I think this is very optimistic. That's way harder today to align an agent. This means that we need 20 trillion tests to run to align this amount of agents in production in the next couple of years. So I don't think it's scaling well. We need a better, we need just to do a better job as an industry to be able to fulfill this and really release agentic AI and AI agents that are really ready for prime time in production. So and this means that we are missing large-scale enterprise-grade adoption right now. So I think we have a glass ceiling that people here in the crowd are very relevant to take responsibility, pun intended, and solve this issue. So we see a bunch of gaps that if we take the gaps that we see right now at ActiveFence that are probably the hardest problems to solve at the moment in order to get there. They are here on the screen. And the reason I'm saying that is that this is what we see right now in order to cross this chasm of responsible agentic AI to get to massive adoption in production. It doesn't mean that this is an exhaustive list. This is just what we see right now. We are going to cover today at least a double click into 2 of them. We'll talk about the problem of not knowing what you don't know. The unknown issue, where if you don't know a specific risk, then you cannot solve it. And what I'm going to do is just walk through the problem first, and then try to sample out the type of things that are missing for us to hopefully inspire you to continue this type of work. So the problem is that we have frameworks for how to test agentic AI, but they are behind because up until now they have been mostly focused on the input-output level and not on reasoning, tool calling, and other aspects that are more unique to agentic AI. And once there are missing risks, then we don't know what to test for, and therefore there's still misalignment in the models because we can't align them well. And in order to do that, the approach that we're taking is we need to build mental models to think about agentic AI risk. We need to build frameworks to actually use them to actually test and find these new risks, and then have catalog of responsible AI, responsible agentic AI, RISE² type of risks. So I'm going to show one mental model, one framework, and then a few risks from the catalog we've been building to give you a sense of what I mean by mental models, what I mean by frameworks, etc. So one mental model is the agentic AI threat surfaces mental model, which means that if we have a mental model in our heads of where are the areas where agents are susceptible for vulnerabilities, then it's much easier for us to test the right areas and find new types of risks. So I'll go through it quickly. The user application level risk, this is where most of the OWASP, NIST, and most of the work has been going on for the past few years, input and output between the application. The application used to have direct connection with the LLM. That's no longer the case, but the attack surfaces there are pretty well tested. But between the agent and the different tools it can call, the other databases and contexts that it can receive and provide, and also the communication with LLM, and then also the correspondence and communication with other agents, these are new attack surfaces that are less explored. But with this mental model in mind, we can build frameworks. So here is an example framework, like a snippet form, ActiveFence Agentic AI testing framework, where we take the different surfaces and we say, hey, how can we be way more efficient when we're testing agents? We don't need to run all evals when we're testing a specific agent. Let's see what type of vulnerabilities exist, attack surfaces, exist, and therefore let's test the right things. For example, if we go back here, if we can trust the users completely, let's say the users are just 3 named employees, then we shouldn't worry about adversarial attacks from users. So we can take malicious users and remove all tests that are related to malicious users. And this can reduce the amount of evals we need to run. So this is a framework that allows us to run tests way more efficiently and do faster feedback loops through that. So these are 2 examples, one mental model, one framework. And without these mental models and framework within your companies and us as an industry, it's going to be much harder to find these risks systematically and catalog them. So here is the catalog. This is like the end result that we're trying to get. So this is an overview of just the taxonomy, not the full catalog, taxonomy of the RISE², the Responsible Agentic AI risks catalog of ActiveFence, where we have the main categories, type of risks that are on the model level, legal, ethical, content, and security. There are sub-category, like prompt injections versus toxicity. And then under that, we have the list of actual attack vectors. So to then show you a few actual risks from this catalog and how they are being used in the wild. So let's take a scenario of an email summarization AI agent. So it has access to all your emails. It can basically draft email and do a bunch of stuff, but the main purpose of it is to do summarization and help you draft your emails, your replies. So here we can show a scenario that with using the new attack surfaces and new risks that are agentic AI specific, this agent can act as ransomware. It's unintentionally. So here is what happened in our testing. So the AI agent goes through the user email inbox, and then it bumps into a malicious email. So all the attacker had to do is just send an email with a prompt injection. And then the AI agent uses this prompt injection in the context while doing reasoning. And the reasoning is hijacked. I will show exactly how. And then the agent runs through other emails, takes the PII, because of the prompt injection, it tries to do that, and then sends it to a bad actor email address. So I'll show the actual risks, that vulnerabilities that were actually being used to do that. So the attacker was able to determine that this model uses a tag called reasoning, which is a common type of tag for reasoning models. And then it uses prompt injection to change or inject additional reasoning into the reasoning of the model. So then it basically asks it to ignore other instructions and go find the other emails with PII and send it over, and the email with the PII was sent. Another approach to do that which is a different risk in the catalog, is reasoning override. From the get-go, changing the whole reasoning chain of thought by completely replacing it. So these are two example techniques. I'll show you one technique that is not on the reasoning attack surface, but rather on the tool calling. I showed before that when the agent corresponds with the LM for reasoning, it can also do tool calling and call different tools. This vulnerability is called direct tool invocation. So instead of telling the reasoning, changing the reasoning, and then hope that the agent will do the wrong thing, then you can actually put in the reasoning what tool to call. And some tools are well known, like sending emails. So by actually calling the function, changing the reasoning to call the actual function, the agent actually sent the email directly. So this is another type. So thank you for joining me today. Please feel free to reach out or check out ActiveFence.com for more information. Thank you.